Okay, guys, and we are down to the final thing on this chapter, which is called expected value, not expected frequency, which we had earlier in the chapter. Expected frequency is where you expect something to happen. Like, for instance, when you flip a coin, the chances of getting tails is 1/2 or a half or 50%. This is a little bit different. This is to do with games, okay? When you play games, and probability, of course, has a lot to do with gambling and things like that, you know. So here we have a spinner. You bet €5, then spin the wheel and you win whatever amount the arrow is pointing to. Okay, so pretty simple. Is this a good or a bad bet? We can decide mathematically by calculating the expected value or mean. The expected value, EX we use for expected value, is defined as EX equals to the sum of X multiplied by the probability of X. Okay, so look, don't worry too much about that. It's fine if you, here's the official formula for those who like that sort of thing. So the expected value is equal to the sum of the outcomes multiplied by the probability of the outcome. Okay, and let me go back over here and we finish out the example that we were talking about. So you have this game here where you can win €2. So I'm on about this game over here. Okay, so you can win €2, €4, or €6. Now, what would you expect to win from this game? We have this formula. Okay, so the expected value is equals to, right, here's our €2. What's the probability of this spinner landing on €2? Well, it's half the circle, half of the circle. So the probability of it landing in this yellow area, probability of it landing in here is a half. And if it does land there, you get €2. Okay, so that's where this comes from. So you get €2 if it lands in that half of the circle. Okay, now what about if it lands in this part of the circle? Well, that is a quarter of a circle. Okay, so a quarter. The probability of the spinner landing there is 1/4, a quarter. And if it does land there, you get €4. Okay, now what about if it lands here? This is where we want it to land. Okay, all right, what about if it lands there? €6. How do we, well, there's a quarter, it's a quarter of a circle, so there's a quarter of a chance of it happening. So you multiply out the yellow bit there. So if you multiplied out that yellow bit, 2 by a half, well, 2 multiplied by a half is 1. What about 4 multiplied by a quarter? 4 multiplied by a quarter is also 1. And what about 6 multiplied by a quarter? Not sure of these. You can do some people do them in their heads. If you don't, just use your calculator. 6 multiplied by a quarter is 1.5. Add them all together, and that is what you're expected to win. Okay, €3.50. That's what you're expected to win. Now, the thing is, though, this game cost €5 to play, and the expected value is €3.50. So you'd end up, losing €1.50. So it's a bad bet. You shouldn't play this game, basically. That is what expected value is used for. Okay. So I suppose if you have to decide whether a game is good or not, if your answer is 0, like we got 3.5 in the last year, €3.50, then the bet is said to be fair. If the value, if it's greater than 0, okay, if it's greater than 0, then it's a good bet. But if it's less than 0, if you get a minus number for this, then it's a bad bet. Okay. Now you will have to take into consideration how much money you pay for this game. Let's have a look at another example. A single card is picked from a deck of cards numbered 1 to 4. So you have 4 cards here. Probability distribution is shown. Okay. Find the probability of picking a card which so the probability of picking a card with the number 1 on it is 0.1. Okay, so a 10% chance. Probability of picking a card with 2 on it is 0.3, so it's a bigger probability of picking that number, 2. What about 3? Okay, it's even a bigger probability, 40% chance, or 0.4. Now, how do we calculate how do we calculate that final empty box? Well, we've done this before. We've done the likes of this before. Okay. Remember, these numbers here, all of them should, those four numbers, we're missing one, but those four numbers should add up to give us 1. So what do I need to add to 0.1, 0.3, and 0.4 to get to 1? Let's go back over here and have a look. So what they're doing here is basically you can do it two ways. You can either add up this, this, and this and take it away from 1, or you can just start with 1 and take away 0.1, 0.3, and 0.4, those numbers over there, and you get 0.2. So that is what should go in to that empty box. 0.2 goes in here. Okay, 0.2. If you want to do a quick check, you may do a quick check by adding 0.1, 0.3, 0.4, and 0.2, and you will get 1. Okay, so that's the first bit. Find the expected value. So the outcome, these are the outcomes. What you can either get a 1 on your card, a 2 on the card, 3 or a 4 there. Multiply them by the probability of getting each one. So what's the probability of getting a 1? It's 0.1. What's the probability of getting a 2? 0.3. Probability of getting a 3, 0.4. Probability of getting a 4, 0.2. Multiply them out. You can do a table like this if you want, or you can just do it the way they did it up here, you know, when we were doing it a minute ago. So it's up to you whether you use a table like this. Table is nice. So when they multiply them out, they get this, 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 and this. But don't forget, in the end, you need to add them all up, and that's your expected value. So the expected value turns out to be 2.7, which is greater than 0. Okay, it's greater than 0, so it makes it a good game to play, probably. There's another example. Okay, I'm not going to go through that. I don't want this video to drag out. I'll do question 1 quickly here, and then I'll give you some work to do for tomorrow. So question 1. Find the expected value when the spinner is spun. Each sector is of equal size. So if each sector is of equal size, then you have a 1 in 3 chance of winning each one. Okay, does that make sense? Okay, so you have a 1 in 3 chance of getting, so 1 over 3. Let's do fractions instead of decimals. So equal size, it says here. So you have a 1 in 3 chance of pink, 1 in 3 chance of blue, 1 in 3 chance of green. Of course, we want the pink there, don't we? Or sorry, the blue, because it's 12 euros. Okay, so expected value. Let me just write it the way they have it. E with a bracket, yeah, around the X like that. So the expected value will be, let's look at the 12 euros. So 12 euros multiplied by the probability of getting 12, so that's 1 over 3, plus, let's go with the 6 euros next. So it'd be 6 multiplied by the probability of getting the 6, plus the final one is the green area. The probability of getting, so 3 euros multiplied by the probability of getting the 3 euros. Okay, let's work out all of these. 12 multiplied by 1/3 is 4, plus 6 multiplied by 1/3 is 2, plus 3 multiplied by 1/3 is 1. Add all of them up together, and we get 7. Okay, 7 euro. So you can expect to win 7 euro from that game. It doesn't tell us how much we paid to play the game, so we don't know. But this looks, let's say it was a free game to play, then obviously it's a good game to play. But there'll be probably, if let's say there was 5 euros to play for the game, well, you can expect to win overall 2 euros, okay? Because your expected win value is 7. Hope that makes sense, guys. As always, let me know if it doesn't by emailing me or get me on Teams, okay? Oh, almost forgot homework. So how do I get rid of this? Apologies. Let's go back. Okay, so homework for tomorrow. Try question 2, 3, 4, and 6, 8, 10. Look, as many of them as you can, okay? If you know, so question 2, 3, 4, 6, 8, and 10. I'll put it up on Teams as well. Okay. Try as many as you can and let me know which ones give difficulty. And see you tomorrow for our last live class before midterm break. Take care.